My name is Matthew Hall, and this is Lab 2, or Lines of Charge. So for this lab, we're doing a lot of it based upon Lab 1, where we were identifying the excess charge on a piece of tape. But for this one, we're trying to use that information and relating it to any differences of charges and forces if the charges were distributed on a rod versus if we were considering them to be a point charge. So a couple of concepts in this lab are Coulomb's law, electric field formulas, so electric force, gravitational force, and whether they are on a line or considered to be a single point, and then the concept of superposition. So some of the formulas you can see on the right side, you have electric force, you have force of gravity, which they're going to be repelling each other, one acts down and one acts up, and that uses a lot of Newton's laws. And electric field is there, and then the bottom formula for electric field is related to if the charges were distributed along a rod, and so the radius and the length there both have to do with a rod. So for this lab, a lot of it was based upon Lab 1. So we used the same materials in the same experiment. The length of that tape was 20 centimeters. The mass of the tape was about 0.0002 kilograms, and the separation was about 2.5 centimeters. And so we had to make a couple of assumptions. Air resistance in this case is not considered to be negligent. The tape is not considered to be a point charge this time because we want the charges to be, we want to see how it's reflected if the charges were along a rod and evenly distributed. So from Lab 1, we want to review some of the results if it were a point charge, which we see our gravity equals our electric force, which should still apply in Lab 2's case. But the important thing to note is that when using the point charge formula, our electric charge is much different. So then it was 1.17 times 10 to the negative 8 coulombs. And now for Lab 2, the value on the right side equals 2.58 times 10 to the negative 8 coulombs. And as you can see in the results, the electric force and the gravitational force are still relatively the same, which means that our value for our charge is reflective of an equilibrium system. And on the left side, there are multiple parts of the code which were used to calculate these values. The top part is mainly used to calculate electric field, and then the bottom part is a step analysis about how each of the fields and the forces were calculated. So some of the final questions to address over this lab was, the first one is basically how can you relate a point charge to the line charge? How are they similar and different? And so the basis of it was, as discussed earlier, it was the formula. So the formula used for calculating a line charge takes into account different values like the length of the rod, which isn't taken into account for a point charge. And so from the experimental data, we can look at it again, we saw that the charge when it was a rod was much greater than if it was just a point charge. And these values, as you can kind of see it in question number 2, how do they differ? They differ greatly because of the fact that the charges are evenly distributed, which is more reflectant of real life, in this situation with the pieces of tape. The tape can't be only reflected as a single point charge, and all of the charges spread across the piece of tape, they all have different forces and different fields that act, and that's where superposition comes in, which is much greater than if the charge were to just be in a single location on the piece of tape.